This is a contactor that was in an interlock system for an electric oven. It was the power feed interlock, so if they had an Ansel issue, the contactor would drop out. When we go out to check contactors, one of the things we commonly do is check the points on the contactor. There's 2 screws here on the front that remove the guard. That is the piece that's supposed to protect any debris from falling into the contact points. Underneath this little guard, you find the actual points for the electrical circuit. This is a 3-pole contactor. So,
that towards me just
sure. So in this contactor, there's 3 conductors that go through, screw lugs and spade terminal lugs. And as you can see, in here, each one is made by a little brass gate. If you gently lift up on these brass pieces and turn them sideways, you can actually take one out and inspect it. This is it. So that these points make contact with those points down there, the circuit's closed and the contactors are able to feed voltage to where it's supposed to. What we don't want to see is a bunch of pitting on these contact points. That'll add resistance. Resistance equals heat. The contactor could fail because of it. That's not the reason that this contactor failed. This contactor wouldn't pull in. This is the magnetic coil down on the bottom of the contactor. It does all the work to pull the mechanical part of the contactor down. But as you can see, I can't even push this one because this coil failed. It actually smoked up, and when it did, it melted down and it doesn't allow the contactor to pull down anymore. So we replaced the entirety of the contactor. The other option is to replace the actual coil. So on this model, it has 2 push tabs, both ends, here and here, and you can actually pull this coil clean of the contactor, which is a nice function when you don't want to carry multiple contactors. A lot of times I'll carry the same brand and the coils themselves will be interchangeable between the contactors. So we know that this coil burnt up, but let's take a look and see why it burnt up. Well, that's it right there, baked off all the way around the coil. When that happens, you see how the plastic bubbled up on the interior of the coil. Now the center pole can't make it past there. So this part right here is supposed to ride clearly through. And you can see there's no clearance for it. So this contactor, the tech couldn't even push closed. And besides smelling, which electrical does smell when it burns, the only other way you would have known what the failure was is to actually see voltage, 120 or 208 volts here, and the mechanical of the contactor not pulling in. Second part is to read it, and when you read it, like I said, the ohms reading for this coil stays the same. OL means open leg. There's no continuity through there, but we can see why. So this is a real easy way to go through a contactor and make sure that A, it's functioning properly, and B, the points aren't so burnt that the compressor or component using the contactor might get fed single phase voltage.